Hello, class. Today we're doing red, red 12.4 or blue 6.4. Today we're learning how to add, multiply, subtract using irrational or radicals, okay, numbers. So let's take a look. I do even, you do odd. On number 2, we have 2 ninths minus the square root of 11 ninths, okay? We use the rules for adding fractions where we recognize that in order to add fractions, the denominators must be the same. In this case, the denominators are the same. So we have a win-win there. So we have our denominator. In this case, our numerators have different identification. One is a whole number, 2. The other one is a radical, which is the square root of 11. Because they are not the same category, same species, same last name, same daddy, however you want to call it, we do not add or subtract those that are not like terms, in that they are two different types of numbers. So therefore, they each keep their unique identity, and that is as far as we can go with this problem. Okay? Let's move forward to number 4. On number 4, we have 3/2 square root of 15 plus a half square root of 15. Now, in a case like this, we see that these can be combined because they have similar identities. They both are being multiplied by the square root of 15. So the square root of 15 stays the square root of 15. However, the two fractions can be combined because they are both fractions, okay? So therefore, we can rewrite this so that we have 3/2 plus 1/2, both of which is multiplied by the square root of 15. So these can be combined so that we have 4/2 square root of 15. Simplify 4 divided by 2, we would get to the square root of 15. And that's how that would be simplified. Now let's take a look at number 6. Number 6 reads 16.4 square root of 21. Okay, minus 15.1 times the square root of 21. Okay, and so once again, the square root of 21 keeps its identity. All right, these are in the simplest form they can be in because they both have the square root of 21. They can be combined through subtraction. So we would take the 16.4 minus the 15.4, simplify that, and then have it with the square root of 21. And so therefore, when we subtract 15.1 from 16.4, we have here, and that's as far as we can go. Okay? All right, let's move on to number 8. On number 8, we have the square root of 32 for number 8. In a case like this, we have 32. We can identify multiples of 32, and if a multiple of 32 is a perfect square, we can take that perfect square and leave the rest under the radical. Okay? So in that case, when we think of factors of 32. We have a 4 times 8 is equivalent to 32. We know that 4 is a perfect square, so we can square root the 4, okay? And so therefore we have 2 on the outside of the radical and 8 underneath because it's not a perfect square, okay? Let's move on to number 10. On number 10, we have the square root of 29 over 81. We recognize that 29 is not a perfect square, but 81 is. So then we can, and then there are no multiples of 29, or no factors, I should say, of 29 that have a perfect square. In fact, 29 has no factors, okay? So therefore, we leave it as is, all right? So that the square root of 29 over the perfect square, we get the square root of 8, which is 9, okay? And that's as far as we can take it. Let's look now at number 12. On number 12, we have the square root of 40 plus 3, the square root of 10, okay? So now we take a look at this and we say, okay, we have a square here and we have a square here, okay? And we know that 40 has some factors in it that we can factor out and find a perfect square, all right? Of that can be 4 times 10. That gives us 40. All right, plus 3 the square root of 10. If that's the case, then we take out this perfect square, which is 2. We're left with 10, which is not a perfect square, and then 3 the square root of 10. Now we can combine the whole numbers, all right, here and here, and now we have 5 the square root of 10. Okay. Moving forward. Those are all the even numbers, but I noted that number 13 appeared to be somewhat challenging, so I will seek to include, do I have enough time? Yes, I will seek to include number 13 in the problem. Here on number 13, we're going to go to the next page. On number 13, we have a building. All right, in our building, we have the square root of 192 feet on the front, the square root of 108 feet here, and then we have the square root of 48 feet here, okay? And so it asks us to find the perimeter of this fine building, okay? And so to find the perimeter, we recognize that we have 2 sides, that's 108, this would be on that side. So we have 2 square root of 108, all right, that's 2 widths, and then we have 2 lengths. So we have 2, 192, and together they give us our perimeter. Okay? Now, in order to simplify this to its simplest form, then we would need to identify the factors, perfect factors for these numbers. So let's take a look. If we have 2 times whatever it is, okay, and we find the perfect factors, we can take our calculators and we can say, okay, let's try 108 divided by 2, and we have 54, which is not a perfect square. Then we say, okay, let's take 108 divided by 3, and we have 36, which is a perfect square, okay? And so we say then, if that be the case, we have 36 times 3, okay? And in this case, we do the same thing. We have 192 divided by 2, we get 96, not a perfect square. 192 divided by 3, we get 64. So we have 2, and it's 64 times 3. So they both, okay, have 3. So let's take a look. Let's go ahead and take the perfect square of this, which is 2, all right, times, pull the 6 out, square root of 3. The 2, pull the 8 out, square root of 3, okay? Now, with that in mind, we would say 2 times 6 will give us a 12, 3, and 2 times 8 will give us a 16, 3. Add together, and we have 28, the square root of 3, and that's what our P is equal to, okay? Now, the next one, it asks us for the volume, okay? Well, you know, volume is V is equal to length times width times height in this case, okay? So let's take a look. Our length is the square root of 192 times our width, which is the square root of 108, times our height, which is the square root of 48, okay? So now, what we have here under our radical is 192 times 108 times 48. All right, so let's see what we have here. 192 times 108 times 48 equals. So that gives us 995,328. Okay, so that's what we are getting. So now, from there, we need to do what we did here before. If we divide this by 2 and try to square that number, it's not a perfect square. If we take the 995,328 and divide it by 3, and take that number and see if we get a perfect square. Yes, we do. So here we go. We're going to take this number and we're going to divide it by 3. So that way we have 3 times 3. This gives us this number here. Now from there, this can be perfect square. So we take this number and square it, and this is what we get, and with a 3 underneath, and we're done. Typically, we can take this, factor tree it down, but that would take too much time, and we would come up with the same results, but that's one way of doing it. But the final answer is 576 square root of 3 would be the volume. Okay? Oops. Okay. See you in the morning.